will be working on for the rest of this week and possibly into next week are exponential functions. But in order to work with exponential functions, you really have to know the rules about exponents, which I'm sure you all have seen before, but you might have forgotten. So that's why we're going to do this chart. So for those of you who are wondering exactly what it is I wanted you to do, I don't know if you noticed, but there are 4 rows that have already been filled out as examples for you. I only want you to do the bottom 4 rows, but looking at the top 4 rows.
Pardon the interruption, please. Students that ride bus 1722 will ride bus 1263 today. Students that ride bus 1722 will ride bus 1263. Thank you.
Okay, so what I was saying is that use the top 4 rows to help you answer the bottom 4 rows. And hopefully, if time permits, we'll be able to do all of this before you leave from class. Alright, the first one that they talk about are the product of powers. And what they mean when they say product of powers, they are saying that you are multiplying things that have the same base. Okay? This part right here is my base. And we do have exponents on each one of those bases. For my first 3, the exponent is a 5. So in expanded form, they wrote that out as 3 times 3 times 3 times 3 times 3. So pretty much 3 5 times. And then you're going to multiply that by the next part, which is 3 to the 2nd power. So that's this part right here, which is 3 times 3. So in simplified form, as opposed to having this or this, that would be 3 to the 7th. Now, something that I noticed certain people doing, and I know it's easy to do, is this. Sometimes you are tempted, when you see 3 to the 5th power, to think that is the same as 3 times 5. That is incorrect.
Really?
Yeah.
3 5 times.
Right, it's 3 5 times. Because 3 times 15 is 3 times 5 is 15, right? Okay, well if I have 3 times 3 times 3 times 3 times 3, so that's 15, 30, 45. 1545?
No, that's not right.
Oh, wait. I cheated myself. Sorry about that. I'm sorry. I'm amused when I mess up in front of y'all. I'm sorry. Okay, so somebody with a calculator, tell me what 3 to the 5th power is. 245. Thank you.
It's 243.
I'm sorry.
243.
I'm sorry. What?
243.
Oh.
245.
Okay, it's 243. Sorry. Okay, so can you see the big difference between 3 times 5 and 3 times 3 times 3 times 3 times 3? There is a big difference. And so that's part of the reason why we want you all to get this notation down. So what we are doing today is finding the composition of functions. So it picks up with a little bit of what we did on Friday, where we added, subtracted, multiplied, and divided fractions. So just as a quick review, if you will go to page 113 and look at example 3, okay, on example 3, there I have f of x equals 2x to the 3rd power and g of x equals x to the negative 1st power. Well, let's just say that I made, let's say, a function table using f of x. When my x equals 0, I plug in my 0 right here for my x, right? Because then I plug in my 0 right in here, and then I put that into my formula to find my answer.
Yeah.
Okay. And so, Devontae, again here, my x equals 1. And so f of 1 is when I plug 1 into my equation. That's why I have 2 times the quantity 1 to the 3rd power, and that gave me 2. And so Darion, for when my x is 2, when I want f of 2, I put my 2 into my equation to find my answer, right? Okay. And so let's take a look at g of x. We're going to do the same thing here. For g of x, when my x equals 0, all I do is plug my 0 in for my x. Okay, so are we all familiar with how to find f of or g of a certain number? Are we comfortable with that? Okay. Janae, what was your question? It's a shortage of math, unfortunately. But I will have it, Janae, I'll have it up on the board in a little bit.
Actually, I don't know if y'all can look, but Friday I had my math book and my geography book in my first period, and my teacher said he called me, but he thought that the person that was supposed to have it was going to me. So I cannot find my geography book or my math book, so I'm not really have to stop.
Okay. See me after class, I can work on either printing out pages or I can show you where to go online so you can do your work. Okay, then we'll print you out some pages. Okay. In this particular problem, my g of x is 3 over x plus 1 and my h of x is x plus 5 over 2. So, Khadijah, what we're doing today when we're talking about compositions of functions, we are plugging other functions into another function. So, as opposed to having just g of x, I'm going to have g of h of x. Yes. It is not as hard. I know some of you are looking like, what? No, it's not as hard as you're thinking. Because remember, we just went over an example of f of 0, f of 1, f of 2.
So you're going to put that whole thing.
And so can everyone see the different colors? Can everyone see that my g of x is black and that my h of x is red? Okay. And like I said, I'm going to take my h of x and put it in as if it were my x into my g of x. So, in g of x, I'm using h of x. So I'm taking g of x plus 5 over 2.
Why you can put the numbers and stuff inside before you see that? Like x plus 5 over 2, why you can put that in different?
What? This?
Yeah, why you put that in different?
In these parentheses right here? Oh, just because I was setting up my problem. So, now that I have g of h of x, I'm going to now take my h of x and put it in for the x in g of x. So, what did I just say? That just means my g of x equals 3 over x plus 1. Okay, well, I just said that I'm going to put in the red for my x. So that's what I did right here. Is everyone with me? If you are not with me, please let me know. Yes, ma'am. Okay. This is not something new. We just did an example. Look, it's the same as what we were doing.
Put the 3 over x plus 1 where the b is.
Hold on one second. Let me see if I can answer this for Janae and Gina. Okay, you all were asking if this is something new. It's the same principles of what you do here. Okay, here, my x equals 0. So for f of 0, I plugged it into my equation. There you go.
Thank you.
Okay, so now we're going to go back to what we were doing over here. And Brandon, what was your question?
Why didn't you put 3 over X plus 1 where G is? Because I thought that's what it is. So why isn't G of X
It's this. Because
So why did you say 3?
why the 3 is right here.
In there. And
Because
not the 3.
The 3 is right here.
On the top.
Because G of X is 3 over X plus 1. And so the red is going in just for my X.
So basically,
So,
your X is just the problem for X of X.
right. Okay, did everybody get that? Devontae, did you get what Darian said?
Yeah.
Okay, so what am I plugging in for what am I plugging in for my X, Devontae? What is my X now in my G of X?
5.
If you're getting warmer, it's that whole thing with the 5. So my H of X is now my X. Okay.
Okay, once you finish the warm-up, please go to page 249 and start reading example 3. E, for the person who said A, why did you say A? Because 0 plus 2 and 4. What do you say the Y is on? It's positive. Yes, thank you. That's exactly what I was looking for. When you have an equation for a line in this form, this is slope-intercept form. And the constant at the end, that's your y-intercept. So that's telling me where this line crosses the y-axis. Here it crosses at positive 2. Because when I looked at this, that's exactly what I did. I looked at the constants for every choice. The only one that had a positive 2 was A. So that told me that should be the right answer. I did it. Well, no, sometimes we'll go to the computer lab because there's something that I want you all to do on mine, but I don't always need to be in here. So it just kind of depends on what we're doing. And just really quick, this is kind of like an unofficial opinion poll. Just raise your hand if you do like going to the computer lab. Because I know sometimes it can be frustrating working on the computers, and even for me, it gets frustrating when I'm trying to pull stuff up or show you all things and I can't get it to work. Okay, raise your hand if going to the computer lab, it's okay, but you can live without it. Just raise your hand if it's okay, but you can live without it. Okay. Raise your hand if you just absolutely don't want to.
Don't go
Go to the computer lab. Like, you really don't see the purpose, or it's too frustrating, you don't really want to. Okay, one more time?
To explain how doing this affects you in the real world.
How what affects you?
What we doing?
Well, actually, I was going to talk about something that I actually did when I was in college.
I want to go somewhere, is what I'm saying.
I know, on the real field.
Well, I'm sorry, undergraduate. Right now, I'm working on my master's. I'm sorry.
I haven't been on good trip. What's the real fifth grade?
All right, so are we on page 249, example 3? Okay, on page 249, Cindy, what exactly are they talking about? What is that example about?
What page is it?
Cindy, who was talking that I called on to answer the question, the information on page 249 talks about finding the median line. Jamie, what does the median line do for us? Well, what have we been doing all week? We've been
It finds the line that like the median of the graph.
Okay, I like your explanation. Jamie said the median line finds the line that is the median of your graph. That's kind of right. But typically mathematically, what I was really looking for, Melissa, is it helps you to fit a line to your data. So when you have a scatter plot, Janae, then it's not always going to be a straight line because your numbers are all over the place. You know, when you have a scatter plot, that's why they look like this. It doesn't look just like this. But by using best fit lines and things like median line, we can draw a line like this. So, Brandis, to help answer your question of when do we use this in real life, I used it not for linear things, but I used it for quadratics. And quadratics are the things that look like that. They look like U's or upside down things, however you see it. Parabola, but it's also quadratic. It's another term for it. And how I use them, because personally I really love astronomy. I'm fascinated by the stars. I don't know. Did anyone look at the moon this past weekend when there was a red? It was red?
No, it was orange red.
I never noticed
It was orange and it's bright.
What time did y'all see when it was red?
It was orange, but it was like orange red.
I need to blow my nose.
Well, hold on. Okay. But on that note, the reason why it looks that orange-red color is because of where it is in the sky and the atmosphere. It has to do with how far away the moon is from us at that particular moment. Did you see it when the railroad was around it? I didn't see all of that. But where I'm going with that is this. When I was in undergraduate school, I did my senior project on a planet that was found. They found a new small planet, and the way that they found it was by something called a wobble. And so, it's a wobble. And what happens is that the data, okay, do I have y'all focused? Are we focused? Okay, the data looks something like this. Now, just looking at that doesn't exactly say, hey, I'm a parabola. However, by using a best fit line, or for this, a best fit quadratic, we were able to draw something that looked like this. So in the real world, that's one example. And then also, raise your hand if you work in retail, you know anyone who works in retail, or better yet, when you go to the store. Okay, what about call centers? Have any of you ever worked in a call center? Do you know anyone who works at a call center?
What is that?
You know the people who call for customer service? So, how they usually book people to work, how they make the schedules is they say, okay, last January around this time, we needed this many people to work because we had this many phone calls. So the same thing is, they use that same type of thing. So again, if we were to represent that on a graph, this were, so if we were to show phone calls, again, it could look something like this. So at this point in time, that tells me I need fewer people on the clock. So as opposed to having 20 people work, I might have 5 people work. Right here, I don't need anyone working. So that means everyone's off. Restaurants also use this same type of method to, when I worked at a restaurant, we call it cutting people. So essentially you work, when it's really busy, that means all hands on deck. Everybody needs to be working. We need everybody. As things slow down, like for instance, Friday nights are typically really busy, 7 o'clock. You know, we need all hands on deck. However, when it gets there around 7 o'clock, Friday night at a regular restaurant around 9 o'clock, you don't need everybody to still be there. So that means you're going to start cutting people. You're going to say, okay, you can go home, you can go home. Personally, I look forward to that time, but so again, that's another way that this type of information is used in real life.
I have a question.
Yes.
Do you use scatter plots with quadratics?
That's what this was over here.
Okay.
That's how to find the moon.
Because I was in a restaurant.
Oh, okay. All right. Now we're going to do a quick flashback. Sorry, I was going to go look up the song Flashlight really quick, but I'm sure you all will sing it for me anyway.
I don't know what you're talking about.
Yes, you do. You
Well, sing it.
No.
What song is Flashlight?
Flashlight, that's it.
How do it go?
Flashlight. And then it goes like, at the end it's like, flashlight, neon light,
Okay.
Anyway. Wow. So, we're doing a flashback to some things that we've done before. Okay. For instance, if we wanted to find the slope of a she said that formula. Khadijah, do you know what formula she's talking about when she's talking about slope? Okay, Janae, can you help her out?
What formula to talk about?
When we're talking about slope. Exactly. Oh, I'm sorry. Okay, so you're exactly right. It's y2 minus y1 over x2 minus x1. So carry on. With the points that we have, I've given you what my y's are and what my x's are. This is just a quick review, so I'm moving kind of fast with this. So to find the slope, we would just plug these things into our equation to get our final answer of -2. So does everyone see how we do that? Yes, we can. If it's not related to this, then the stuff on the board, I just scroll it down. It's hard for me to learn that because I don't, it's easier to understand for to write it out. So like if I were to write it out as I was doing it, okay. Truthfully, I would love to do that. It's just that because if this is the only thing about our education system is that we have so many things that we have to cover in so little time that I literally am like running through everything. So that is how I feel. But truthfully, I would prefer to write it out. But that is probably the reason why I do it like this. So if if you ever feel that, hey, I kind of got it, but I kind of did because you were doing that thing, could you let me know? And I will try to send you the flip chart individually so that way you can look through it on your own. Would that help?